Hello everyone. Welcome to GoVMlab Why Engineers Fail series episode number 3. Now, most VMware engineers know how to create data stores, right? It's pretty easy. You have to click next and finish. And I believe everyone can do that who are coming from VMware background. And as you could see that it's pretty easy to create this VMFS data store. But enterprise interviews do not test your data store creation. They test something much more dangerous. What happens when your storage suddenly disappears? And that's where you can see these APD alerts. What happens when your all paths are down and your data store becomes inaccessible? What happens when my VMs become unresponsive? Enterprise interviews test that what happens when my VM freezes, my application stop responding, and suddenly my production environment begins failing. That's the moment most engineers realize that they understand VMware screens, they understand VMware UI tasks, but not the storage behavior. If you really see this APD, PDL, data store inaccessibility, these are not certification keywords. These are real enterprise production failures, as you could see that. And during interviews, this is exactly where most engineers fail. And that's what you could see that this is the real state of engineers where they appear in the interviews and they face rejection. And the reason is that because most of the enterprises are not testing whether you memorized steps, whether you understand the steps to create data store, whether you understand how to click and how to finish certain tasks. The enterprises are testing how ESXi behaves during storage failures. And that's the reason we keep saying that certification oriented learning will always help you to administer the environment. It always prepare you to pass the exams. But the enterprise interview test how do you behave when storage failures? How can you handle the failure in the production environment? So welcome everyone to the series Why Engineers Fail, episode number 3. And in this particular series, where we break down the real enterprise VMware concepts that most engineers memorize but never truly understand. So today, in this particular lecture, we are going to focus upon very specific scenario about vSphere storage. And we will tell you or explain you the reason why most VMware engineers fails in storage questions. Because we discussed that most of the engineers know how to create a data store, whether it's being VMFS data store, whether it's being NFS data store. But very few engineers understand how ESXi behaves during storage failures. And today, in this particular lecture, we are going to talk about those storage behavior. We are going to walk you through and we are going to give you the glimpse of real storage failures like APD, like PDL, like path failures, not from a GUI perspective, but from a real enterprises and real infrastructure thinking. So with that, let's begin. Now the real problem. So this is the actual problem which we have been keep discussing throughout our discussions. Most VMware engineers begins here. They start learning tutorial, right? They start watching tutorials on various platforms, various uh, documentation, blogs, KB articles. They start learning how do I go and create data store? How do I go and format a certain LUN with the VMFS data store? How do I create VMFS volume with the various versioning, whether it's VMFS 5, whether it's VMFS 6, through your vCenter wizard? And honestly, that part is really easy. Any one of you can raise your hand and tell me how many times you find data store creation a much more difficult task. And that requires a real engineering knowledge for creating the data store where you just have to define the name of the data store, the version, and certain partition configuration. And that's the beauty of VMware, where VMware has created that UI so intuitive that anybody can go and create a data store, and VMware make sure that the data store creation looks very easy to you, because data store creation is just a 5-step workflow where you create data store, you select the disk, you format the VMFS version and finish. That's what it is. And that's create a really dangerous illusion among engineers. And the illusion is that everybody starts feeling that this is what VMware vSphere storage, and the storage is very easy, right? But the production environment will tell you a very different story. Something like all path down. Because in production, the storage failures don't look like a tutorials. In production, the storage failures look like something like this. What do you see on your screen? The production storage failures will be about data store inaccessibility. The production failure will be about your all paths are down. Your VMs are getting freezed. Your applications are becoming unresponsive. Your heartbeats are timing out. Your storage is having a latency. And suddenly, the engineer who was comfortable creating VMFS data store, the engineer who was comfortable managing this data store doesn't know what's happening anymore when he come across with these kind of challenges, that these kind of failures in the real production environment. Because enterprise storage is not about just creating data stores. Enterprise storage is about understanding the storage behavior. And this is exactly where interview becomes a really difficult. Because as you know, the interviewer are not testing whether you know a VMware workflows. Interviews are not testing that do you know the UI workflow and certain buttons where you click and do certain operations. The enterprises interviews are really testing that do you understand storage failures. They are testing how do you think during those storage failures. Enterprises interviewers are testing your real VMware skills, that can you identify all path down kind of failure? Can you identify a certain path failures? Can you identify a SAN visibility issue? Can you identify a VM freeze behavior or VM not responding behavior? And this is what separates a basic VMware learning from enterprise infrastructure thinking. And that is the exact reason why many VMware engineers, in spite of having VMware knowledge, in spite of having VMware certification, in spite of having VMware experience, they face rejection during interviews. Not because they don't know VMware, but because they do not understand the storage behavior. Most engineers always focus on learning data store creation, But the reality is that the enterprise test your storage behavior. The enterprise test your understanding with the storage failure. And that's exactly what we are going to break down in this episode and gonna give you a glimpse of understanding that what enterprises are actually test. And as we keep saying again and again, enterprise do not really care how do you create data store. They care how ESXi behaves when storage fails. So let's understand, guys, the real difference. And if you really see, this is what most engineers study. The engineers, most of the engineers study the steps to create data store. They understand the UI workflow and going through that UI wizard to do certain operation. They understand that how do I format any of the data stored with a certain version, maybe VMFS 5, maybe VMFS 6. They learn that how do I configure a basic iSCSI connectivity? How do I go and discover the LUN on my ESXi host where I can do a data store creation or I can map this particular LUN to my virtual machine as a RDM. So they do understand the basic iSCSI connectivity and obviously a certain basic setting options or default option. And again, I keep saying that there is nothing wrong with learning these things. In fact, these are the first things everyone learns it because these are the important fundamentals and they are really good for labs. They're really good for the labs. But the point here is that because this series, we are focusing upon why engineers fail in interviews. And this is where this slide says that if you really see, you are learning all these steps, and these are very important fundamentals to learn. But from the interview perspective, your enterprise actually testing something else, something completely different. Enterprise want to know, can you troubleshoot the SAN visibility issue? Do you really understand what zoning is doing, what LUN masking is doing, what is the path availability? Enterprises are testing. Can you explain multipathing intelligence? Can you explain how multipathing behaves in VMware vSphere storage? Can you explain the path selection policy, the failover policy VMware is having it? Can you explain how this path selection policy react when any of your active path fails? Right? The enterprise test. Do you really understand what is APD behavior? All paths down. Do you really understand what happens when suddenly all of my storage path disappear? And why my ESXi is continuously doing retrying? The enterprise test that do you really understand why my VMs are getting freezed? Right? That's the difference. Enterprises are testing, do you really understand about PDL? What happens when storage is permanently removed? Enterprise want to know, do you really understand in the case of PDL, why ESXi is not retrying and what exactly my VMCP is doing it. Enterprise are testing that do you really know when does VMCP start recovering your virtual machine in the event of failure. Enterprise want to test that do you really explain, can you really explain the VM restart behavior? Can you explain the dependency logic of vSphere HA and the data store heartbeat handling? Can you explain what happens in the event of storage failures? What my data store heartbeat is doing it and how my storage recovery decisions are being made. This is the real enterprise thinking, I would say. Right? And if you really see, the enterprise engineers do not just focus on data store creation. Enterprise engineers do not only focus on formatting a certain LUN with the respective VMFS version or doing certain iSCSI connectivity. The enterprise really want to understand the entire end-to-end storage path right there from the storage array to your SAN switches, to your HB adapters, to the ESXi host, and to the data store, and last, your virtual machines. This is where industry want enterprise engineer to understand that do you really understand the end-to-end storage path? Do we really understand how my SCSI command travels all the way from these layers to the infrastructure, not just creating a data store? And this is exactly why many engineers struggle in interviews. Because most of the administrators and most of the L1, L2 engineers, they are completely studying and focusing on these various screens, the various UI workflows, while the enterprises are testing your actual infrastructure behavior. So now let's move in to our first real production scenario, right? And this is what this slide says that, right? Which I keep repeating again and again, that always remember the enterprise engineers do not memorize steps. Enterprise engineer understand the infrastructure behavior, the end-to-end storage path. And that's what differentiate them with the normal administrators. So now here is your first question on the screen. As you could see that it's a very basic question, and that's the reason we have marked it as a L1 level of question. So we understand and we assume that every VMware engineer who have a basic level of VMware understanding, they should be able to answer this particular question. And here is the question on your screen, guys. A shared VMFS data store is mounted successfully on ESX host 1, but it does not appear on ESX2 after performing a storage a rescan, right? So now what should be investigated first? So you as a VMware administrator, VMware L1 engineer need to find out that if VMFS data store is mounted successfully on one ESXi host, but it does not appear on the ESXi host 2 after the successful storage rescan, what should be investigated first? And here is your option. The option A says that data store heartbeat region corruption. The option B says that path selection policy mismatch. The option C says that same SAN, fabric zoning, or HBA path connectivity issue. And the D says that VMFS file system corruption. So let's take a pause here of 5 seconds and just type your answer in the chat box. And let's see that what do you guys think about this, one of the very basic scenarios. So now I could see the majority of the learners have the mixed answer. Someone have opted for the option A, someone has opted for the option B, someone has opted for the option C, and similarly, some of the learners have opted for the option D. So we have a mixed response here in the chat box. So now let me break down each of the option carefully for you guys, right? Because we always believe that enterprise troubleshooting is not about guessing. This is not any certification exam where some guesses can help you to crack the exams, right? But enterprise troubleshooting doesn't work on guessing the answer. Enterprise troubleshooting is about the logical elimination of every single option. So now let's take option number A. Now the option number A says that the data store heartbeat region corruption, right? Now, I assume that everybody knows about heartbeat regions, right? Heartbeat regions are used by VMware vSphere high availability feature. This heartbeat region is used to validate data store accessibility between your host. But think carefully, guys, here. If ESXi host 2 cannot even see the data store, which means heartbeat communication won't even start yet. My heartbeat communication will only start when my host first sees the data store, because heartbeat validation happens after the data store get visible to your ESXi host. So certainly heartbeat corruption can never be the first thing you will be investigating it for the given scenario. So now that is a logical reasoning that why heartbeat region cannot be the right answer, because here we already mentioned that the data store is mounted successfully on ESX1, but it is not appearing on the ESXi host 2. So that is the reason the first option A, heartbeat region corruption, cannot be the right answer. Now let's move on to the option number B, the path selection policy mismatch. Now, when you talk about path selection policy, I hope everyone would have learned about multipathing policies in vSphere environment. We have policies like round robin, like most recently used, like fixed path policy. But guys, again, think logically. What your path selection policy controls, right? Your path selection policy controls how ESXi will be using the available storage path. Your round robin policy, your MRU, your fixed path policy will help ESXi host to decide which path to use to forward the storage commands, not whether storage becomes visible. That's not the job and that's not the function of path selection policy. If the data store is completely missing from ESXi host 2, then the more host likely does not even see the storage device yet, right? If my ESXi host doesn't even see the device, the storage device, then how could it can define the path selection policy, or how could the path selection policy can be the reason? Because if the visibility itself is missing, then in that particular case, your path selection policy cannot be the right step for the investigating this particular issue. So certainly, path selection policy cannot be the correct answer and should not be the first investigation point for this particular failure, right? So this is how we eliminated logically the option A and option B. Now, before we come to the option C, let's try to look at and understand the option number D. Now, what this option number D says, VMFS file system corruption. Now, ask yourself this is again. If my VMFS file system itself was corrupted, would host 1 still mount the data store successfully? No, right? So probably not, because VMFS corruption would typically affect all the hosts which are accessing that data store, right? Because if one host has successfully mounted VMFS data store and other host is not able to mount that same data store, which means that VMFS corruption cannot be the right reason, because VMFS corruption would typically affect all the hosts which are trying to access that same data store. We do see in this particular scenario, the host 1 has already mounted that data store successfully. It is just that the other host is not able to mount it, right? So this is my ESXi1 and this is my ESXi2 and this is my shared data store, the VMFS data store. This guy is mounting successfully. The issue with this guy. So host 1 is already using the data store successfully. So VMFS corruption again becomes a less likely investigation point. So again, we should first validate the reason why this ESXi host 2 cannot see the storage device, because it is not able to see the storage device, and that could be the reason why VMFS data store cannot be mounted successfully. So now we are just left out with the last option, which is option number C. The option number C says that SAN fabric zoning and the HBA path connectivity. Now at this stage, this looks to be the most logical answer. Why? Because before VMware can mount VMFS volume, the ESXi host must first discover and see the storage device. As a ESXi host, if I cannot see the storage device, if I cannot discover the storage device, that means the discovery we know depends upon zoning, LUN masking, HBA visibility, and path connectivity. So if your host 2 cannot communicate properly with the SAN infrastructure, the data store will never ever appear, even after rescan. And this is the key enterprise troubleshooting mindset, guys. And I hope by now you would have understood that option C is the logical answer for this particular scenario, and your investigation should always be starting in this particular scenario from your SAN fabric zoning or validating the path connectivity to make sure that why ESXi host is not able to discover the device, right? So now that is the answer of this particular question number one. And as I said, it's one of the very basic level questions. And that's the reason it is usually being asked at the very introductory fresher level, or maybe 1 or 2 years of experience guys who are working as L1 engineer. And you as a L1 engineer still see something new you are learning, right? I would say that's a point for you to understand and realize the reason why the rejections are happening, right? So let's visually understand how storage visibility actually flows in your enterprise infrastructure, right? So let's try to understand the storage visibility exists at every layer before your ESXi can access the data store. So now let's visualize what actually happens. So if you really see that, right, this is the core idea. Before ESXi host can mount a VMFS data store, it must first detect and communicate with the storage device. That means VMFS mounting is not equal to storage visibility, right? The first, you have to make sure that the storage device has to be visible to ESXi host. Then only the VMFS mounting will succeed, right? VMFS data store will be created. So the storage visibility is something you should always looking at first. So now let's look at carefully at this workflow. See, as you know, and you must be knowing, storage begins inside your storage array. In storage array, a LUN will be presented, right? And then the traffic moves towards your SAN switch. SAN switch is something where the zoning has to be done. The zoning must be correct. SAN fabric connectivity must exist. Sorry. SAN fabric connectivity must exist. And once zoning is done correctly, from there, the ESXi host receives storage. And how does it receive? It receives storage via HBA, your host bus adapter. And this is very important, guys. If my HBA of ESXi host 2, as you could see that the HBA of my ESXi host 2 cannot communicate properly, my ESXi will never discover the storage. And this is what you could see that your ESXi host 1 is able to communicate to the storage end to end. That's the reason we do see that the data store is accessible. But on the ESXi host 2, the HBA was not able to communicate properly. And maybe that is where the issue was. And that's the reason the ESXi host was not able to discover the device. And this is exactly the reason why your ESXi host 1 can see the data stored successfully. But now if you look at the ESXi host 2, because of the path connectivity issue, maybe because of zoning, maybe because of LUN masking, maybe because of the cable failure, maybe because the SAN port is down, or maybe the connectivity issue, and that is the reason your ESXi host 2 cannot communicate with the storage device. So what happens? Because the connectivity issue is there, ESXi cannot discover that storage device, the data stored becomes not visible. And this is the key point, guys. The data store problem actually begin even before VMware. And this is what we have discussed in our previous episode also, when we were discussing one of the very common networking scenario, where the VM was losing network connectivity, and the reason was happening even before the virtual switch come into the picture. It was happening because of the issue with the underlying physical network connectivity. And the same logic applies here also. As you could see, the data store problem actually begins even before VMware layer, because storage visibility problem begins before the VMware layer. And this is exactly the enterprise engineer mindset and the strategy to identify and root cause the problem, because you will have to validate the SAN visibility, right? You have to validate the certain checklist, as you could see, that whether my HBAs are online or not, whether my zoning is correct or not, whether my LUN masking is configured properly or not, are my storage paths active, did my rescan completed successfully. Only after all these checks succeed, you should start the VMware level troubleshooting workflow. And this is mindset is what separates a basic VMware administrators from enterprise infrastructure engineers, guys. So as you could see, the storage visibility problem begins even before the VMware layer. And that's what we are keep saying, that just creating a data store, selecting that disk and formatting it as a VMFS version will not help you to crack those enterprise interviews. Because enterprise interviewers are not testing what steps you remember, what you have learned. Enterprise interviewers are testing the real infrastructure behavior, the real end-to-end workflow and the path. So now that's one of the very basic question, guys. And that's what our L1 level of question. So now let's move on to a little bit more advanced production storage failure scenario. Now, before we move further, guys, if you are finding this series, this lecture, and this knowledge useful, then you are exactly the kind of engineer GoVMlab was built for. Because our goal is very simple: to make enterprise infrastructure learning a more practical, more simple, and make it more real, which align with the real production environment issues. And honestly, guys, creating this kind of deep dive enterprise grade content takes a lot of effort, a lot of research around real production scenarios, breaking down those scenarios and giving you some architecture level mindset. So if this video is helping you to understand VMware beyond certification, memorization, beyond UI based knowledge, then we would really request you to please support our channel. Please like, share, and subscribe to GoVMlab YouTube channel. Share it with your friends, colleagues, and engineers who are struggling with VMware concepts. And most importantly, please subscribe to our channel, because every like, every share, every subscription help us to create more enterprise grade content for the entire community of GoVMlab learners. At GoVMlab, as you could see, that we focus on real production scenarios, not just these theoretical slides. and certain workflows. We break down deep dive enterprise concepts in a practical, easy to understand way, right? So keep supporting, keep learning, and let's grow together as enterprise engineers, guys. So if you have not subscribed to GoVMlab YouTube channel, I would request everyone here, please take a pause and click on subscribe button now. And let's continue with the next enterprise storage scenario. Our question number 2. So now here is our question number 2, a little at the L2 level. So if we are working on L1, L2 profile, then this is the question for you. So let's look at the question. What it says that during a SAN fabric issue, multiple VMs become unresponsive. The data store remains mounted. This is the key thing, guys, you have to focus on. The data store remains mounted, but ESXi continuously retry. Look at that. One of the key things you need to understand and focus upon. ESXi continuously retries storage connectivity, expecting the path to recover. Now, what condition most likely occurring in this particular scenario? Now, this question is very important, guys, because this is where many engineers, in fact, many enterprise engineers also get confused. Here is your option. So your option number A, PDL, which is a permanent device loss. The option number B, which is your APD, all path down. This is your option number C, which says that data store heartbeat failure. And the option number D says that multipathing policy corruption. So now let's take a pause here for 5 seconds. Quickly go through this option and please type your answer in the chat box. Your time is up now, guys. And thank you everyone once again for participating in this webinar so proactively. And we have seen a bunch of responses in our chat box. And we could see that again, we have a mixed response where majority of the learners have been selected option number A and option number B. So we do see that the majority of the learners, like 60% learners, have opted for option number A and option number B, where some of the learners have opted for option number C and option number D as well. So now again, we have a mixed response. So now let us break down each of the option for you guys and have a logical elimination of each of the option. No guessing, right? So let's look at the option number A. Now the option number A says that permanent device loss. Now ask yourself this in the question. If this is the PDL condition, if this is permanent device loss condition, does my ESXi will continue retrying? Yes. But in PDL, ESXi does not keep retrying forever. That's the difference you need to understand. Because the PDL says that the device is gone permanently. ESXi accepted the loss of the storage device, and that is what the whole reason why PDL condition occurs. Right. So now this question says that ESXi is continuously retrying. So the continuous retry behavior does not align with PDL. So that is the logical elimination of this particular question. Right? Now, before we move on to the option number B, let's look at the option number C, which says that data store heartbeat failure. As you know, heartbeat mechanism are mainly used by VMware vSphere HA, and that's what we have discussed in the previous question as well. Heartbeat mechanism are used to validate data store accessibility between the ESXi host. So now look very carefully at the symptoms where VMs are becoming unresponsive and ESXi is continuously retrying your storage path, right? Because if you see the hint says that VMs are becoming unresponsive and ESXi is continuously retrying. That behavior point towards this behavior point towards a storage path connectivity issue, not specifically heartbeat logic, right? And that is exactly the reason this cannot be the right answer, right? Because heartbeat failure comes later. Let's look at the option number D, the multipathing policy. It says that multipathing policy corruption. Now, multipathing policies, we all know, controls how ESXi selects and uses available path. Like you have a policies, as we have discussed in the previous question as well, round robin, most recently used, fixed path policy. Now, these policy help ESXi to decide to select the available which path to use. But in this scenario, all the storage paths are impacted during a SAN fabrication. Now, this problem is much larger than just a policy problem. And more importantly, the key clue, which I was also mentioning during this question, that ESXi is continuously retrying connectivity. And that retry behavior is very important. And that's the clue for this particular question. So certainly, multipathing policy corruption cannot be the right answer. Data store heartbeat failure is not the right answer. PDL, we have explained why PDL cannot be the right answer for this specific scenario. So now the only logical answer looks to be all path down, your option number B. This option number B, APD scenario, all path down scenario, aligns perfectly well with this problem statement. Because during APD, during all path down, all the storage path becomes unavailable. That's the whole meaning of all path down. But the point here to understand that ESXi still believes that storage might return. The storage may return. And if ESXi has a hope that storage may return, then what does ESXi will do? It will keep retrying again and again. And it will be keep retrying and hoping that my SAN path will recover during this waiting period, right? I mean, obviously ESXi is expecting that my SAN path will recover because this is the APD situation where some intermittent failure might have happened. And I'm expecting the SAN path to recover. And obviously, during this waiting period, when ESXi is waiting for the path to recover, VMIO might hang. And it will hang basically, right? The VMIO will hang. Your VM will become unresponsive. Your application might freeze. But the data store may still remain mounted. And that is exactly what make APD so confusing for many engineers, right? So that's what it is, guys. So as you could see that the correct answer for this given scenario would be your APD, all path down, because ESXi still assumes that the device will recover soon and it's keep retrying. So now let's move on to the visibility workflow. So now let's visually understand the APD actually behaves, how APD actually behaves inside ESXi host. So let's have a bit more understanding around APD. So we'll understand the all path down storage behavior. Now, this is very important, guys, where APD becomes very important because many engineers hear the term all paths down, right? But very few engineers truly understand how ESXi behaves during all path down condition. And believe me, this behavior is really critical in enterprise storage troubleshooting. So now let's first understand the core idea. APD is a temporary uncertainty condition. All path down is a temporary uncertainty condition, a temporary condition where ESXi loses connectivity to all paths to the storage, but expect them to come back. That's the key thing. ESXi still have a hope for this path to come back, the storage to come back. And that belief changes everything, right? That's the belief which changes everything. So if you really see the first step, the SAN failure, right? So now let's walk through the entire workflow where the first step, as you could see that, a SAN failure. A SAN fabric issue occurs. Maybe because a switch failure is happening, maybe zoning issue is happening, maybe port failure issue is happening, maybe your cable is disconnected. We don't know. There could be many reasons. And suddenly, because of many of these reasons, as I have said, the switch failure, the zoning issue, the cable connectivity issue, because of any reason, this connectivity might break. And suddenly, your storage communication path breaks. This is the path, what we are talking about, right? The step two, when all active storage path goes down, ESXi loses communication to the storage device. And that is where your ESXi host loses the communication to the storage device. But this is very important, guys. ESXi does not immediately assume that data store is permanently gone. This is the key thing where you need to understand that in this scenario, ESXi does not assume immediately that the device will never come back. And that is where, if you see, the ESXi has a hope for that device to come back. So instead, ESXi start retrying again and again, and expecting that storage path to recover. And this retry behavior is the defining characteristics of all path down. The ESXi is basically saying, maybe the SAN will return. Maybe the path will recover. And instead of reacting immediately, ESXi waits. And that is the reason your data store remains mounted. And this is the exact place or exact point where many engineers get confused. And I've seen many interview questions or many interview rounds that people get confused between APD and PDL. Sometimes randomly they say PDL, sometimes randomly they say APD. And that is the exact reason we are saying that many engineers get confused at this point because the data store may still appear mounted. And that creates the illusion that my storage is still healthy. But in reality, the host cannot communicate with the data store anymore. So the data store is mounted, but the storage access is broken. So your data store is still mounted, but your storage access during this period is broken, right? And then, because now the real production impact begins. So this is the scenario we have discussed, but the real production impact will begin right here, where your VM IO will hang, your VM will freeze, your application will stop responding. Why? Because the VMs are waiting for the storage responses that never arrive. And from the application perspective, the application which is generating these IOs, from that application perspective, everything appears to be stuck. Right. So during APD, as you could see that what happened, my ESXi continuously retrying the path. The data store remains mounted. My VM IOs are getting hanged. My ESXi is waiting for the storage recovery. And this waiting period can continue based on something called APD timeout window. Right? The APD timeout window. And what is that APD timeout window? As you could see that ESX wait for the path to return based on APD timeout window is like somewhere around 140 seconds, or it could be longer depending on certain configurations you do, right? So that's the core enterprises insight, guys. And this is the most important concept. APD represents, and that is where I want to highlight again and again that APD represents temporary storage uncertainty, which means ESXi still has hope that storage may return. And that is the reason instead of reacting immediately, it waits. And if you truly understand APD, you will troubleshoot enterprise storage issues much faster. Why? Because majority, or in fact, more than half of the production storage incident happens because of these kind of scenarios, right? So now let's move into an even more critical scenario where ESXi no longer wait, right? And that leads us to our very last question of this particular series or this particular lecture is our question number 3. So now the question number 3, which is a L3 level question, which says that a storage administrator accidentally, now this is important thing, removes a production LUN from the storage array. Immediately after removal, ESX stop retrying storage path. It affected devices become permanently unavailable. VMCP start restarting impacted VMs on healthy data stores. Now, which condition is most likely occurring? Right? So now your options are option number A, APD caused by intermittent SAN fabric failure. Option number B, the PDL triggered because of the permanent device removal. Option number C, your path selection policy failover instability. And option number D, which says that VMFS heartbeat timeout condition. I hope by now you would have got the clear understanding, a clear logical elimination of all the options. And by now, I assume and I hope that each one of you who have joined us in this webinar today should be able to identify the right option for this particular question, because I think we have covered everything around this particular failure scenario. So now let's take a 5-second pause here. I want everyone to drop your answer in the chat section and let's see that. What do you guys think for this particular scenario? The real enterprise storage failure behavior. And now, as I have assumed it, 80% people have answered this question correctly, where they have selected the answer option number B, where some of the people still looks to be confused, and the 20% people have opted option number A still for this particular scenario. But the good thing, what I have seen that none of you have opted for the option number C and option number D. And that is what we have been expecting from you guys. Now, that's the whole purpose why we have created this series and why we are taking a one real production scenario and helping you guys to understand. Because now coming from question number 1 to question number 2 to the question number 3, at least I could see that all of you guys have built that enterprise engineer mindset where you have very straightforward and clearly neglected the option number C and D. And good thing is that 80% people have still opted for this particular question. And that's the outcome. What do we really expect from our every lecture, from our every training programs, right? So now let me break down each of these options for you now again. And let's understand why for this particular scenario, the option number B, the PDL is the right answer, right? So now let's look at the option number A, APD caused by intermittent SAN fabric failure. Now think carefully what we have discussed in the previous question. In APD, does ESXi stop retry? This is what you really need to understand. Does ESXi stop retry? The answer is no. In fact, we have seen in the previous scenario where in the APD condition, ESX continuously retrying behavior. ESX is continuously retrying, and that's a behavior, what we have seen. And that continuous retrying behavior is the defining characteristics of APD. Because the ESXi still has a hope that my storage device will return. But particularly in this scenario, if you have observed, production learn have been removed accidentally, which means the ESXi will stop retrying completely. So does this behavior align with APD? Answer is no. This behavior does not align with APD. Now, before we move on to the option number B, let's look at the option number C, which says that path selection policy failover and stability. Again, it looks a bit more technical, but we all know and we have discussed multiple times that path selection policy controls how your ESXi selects the available path based on round robin policy, based on MRU policy, based on fixed path policy. But in this scenario, the entire storage device has been permanently removed. This is much, much larger than your path failover behavior. And more importantly, you should have noticed that VMCP start restarting your impacted VMs, which means your VMCP recovery has already started. And that clearly indicates this is a major storage loss condition. And that is the exact reason this cannot be the right answer. So now let's move on to the option number D, which says that VMFS heartbeat timeout condition. VMFS heartbeat timeout condition, as obvious, we have discussed. Heartbeat timeouts again are related to host communication. It is related to your vSphere HA coordination. But look carefully at the symptoms. Your permanent device unavailability, your ESXi stop retrying, your VMCP start recovering your VM immediately. This cannot be the right answer then, because that clearly point out towards PDL condition, which is your permanent device loss, not heartbeat. And that's where we come to our last option, which is option number B, permanent device loss. And this particular option aligns perfectly well with this scenario, because the storage administrator physically have removed the production learn. This cannot be temporary uncertainty anymore. And this is what we call confirmed permanent loss. And during PDL, ESXi behaves very differently compared to APD. ESXi stop retrying because now it understands that device will never come back. The storage device is permanently gone. So instead of waiting, it immediately marks that device permanently unavailable. And that is where your VMCP workflow triggers and start recovery. It starts that VM recovery behavior. And that is where your entire VM recovery happens. So this is the biggest difference between APD and PDL, guys, where in the APD, ESXi wait, but in the PDL, the ESXi react to that situation. So the correct answer is option number B. So now that's the correct answer of this particular scenario. The option number B, your permanent device loss. Now let's visualize exactly how PDL and VMCP recovery behave inside your enterprise infrastructure. And this kind of failure happens, right? So now if you really see that, what is happening in PDL condition, right? What is happening in the PDL condition? As you could see that VMware HA recovery becomes very intelligent. And during PDL, we know ESXi does not no longer wait. It reacts. And that's where the VM recovery happens. And that is where the VMCP takes over. So if you really see that, what is PDL? PDL stands for permanent device loss. A condition where a storage device is no longer available and it will never return. In PDL, ESXi stops retrying. It stops all the retries and the loss is accepted by ESXi host. And that is where it triggered the VMCP workflow for the VM recovery. Right? So that is where, as you could see that, the storage array, removes the learn. Maybe it could be accidental deletion. It could be learn unrepresentation or misconfiguration issue from the storage administrator side, because of which accidentally the learn got removed, and immediately that device disappear from the infrastructure itself. And then ESXi receives your permanent loss. Right? ESXi understand this storage device is permanently gone, and it marks it unavailable. It permanently marks this device as unavailable. And that's where your recovery phase happens. Your VMCP detect that impacted VMs cannot continue operate on that storage. And that is where the recovery takes place. And that's where your VMCP get into action. And your VMCP will start impacted VMs on your healthy infrastructure, healthy host, healthy data store, healthy storage path, which you could see it here. So your VM recovery happens and VM move from unhealthy storage to the healthy storage, healthy data stores. And that is why the PDL recovery, and that is why the PDL recovery is much faster than your APD. Because APD waits where PDL reacts immediately. So during PDL, ESXi stop retrying the lost devices. The device become permanently unavailable. VMCP initiate recovery. HA will restart your impacted VM and service restore on the healthy infrastructure. And this behavior is extremely important, guys, inside production environment, because VMware now prioritize your faster recovery instead of waiting. And that's what the key thing here again and again. In PDL, your recovery begins immediately. Because in PDL, your ESXi accept the loss and your VMCP ensure business continuity. And this is exactly the kind of storage behavior enterprise expect engineers to understand. Right. And that's where let's try to have a quick recap of enterprise thinking, the mindset shift, right? Because your enterprise thinking always talk about layer by layer approach, right? If you really see, your real enterprise engineers troubleshoot storage layer by layer. And this is what I have seen missing in many of the VMware engineers. If something is not working, suddenly my VM get freeze, my VM get unresponsive, my VMs are not responded, my data store become inaccessible. They don't have any clue, and sometimes they get scared that what am I supposed to do? And that's what differentiate administrator to the enterprise engineers, because real enterprise engineers troubleshoot the storage layer by layer, all the way from your storage layer to the connectivity layer, to the fabric layer, to the SAN layer. And then it looks at the VMware layer. So enterprise engineers do not panic. They do not randomly reboot the host, and they do not immediately blame a different layer vendor solutions. Enterprise engineers follow a very structured thought process, which you could see that, right? This is the exact stack the enterprise engineers follow. And that's what it really important for an enterprise engineer to understand. Now, once failure happens, the enterprise recovery mechanism also takes over, right? And that is where your high availability, VMCP, multipathing, failover logic, and your recovery workflow will come into the picture, right? And this is exactly the mindset what we are talking about. That first, you need to understand the visibility. Can I see the storage? That is the first thing you should be looking at it. Can I see the storage? Then it comes to the connectivity. Can the host communicate with the storage? Then it comes to the path. Do I have any healthy path? Then it comes to the VMFS, that is my storage accessible. Then it talk about your protection of those workflow, and can my services recover those VM successfully from the failure. right? And this is what the real difference between storage engineers, a storage administrator, I would say, than enterprise engineers. Your storage failure exposes your real infrastructure thinking, guys. Storage engineers, enterprise storage engineers understand the whole stack and layer by layer, right? So that is what I would say. The enterprise infrastructure stack, you need to understand layer by layer. And honestly, everything what we have discussed in this video, guys, honestly, whatever we have discussed in this video, guys, it's just a glimpse of how enterprise engineers actually think. Because real enterprise VMware learning never ever happened just memorizing certain steps. It always happens through your architectural thinking. It always happens through your production troubleshooting. It always happens by layered approach, understanding every layer into that architecture. And that is what I always say. How would you troubleshoot any problem when you don't even understand the architecture? Because troubleshooting is a mindset you need to develop. And I think with this video, you would have understood that why I always saying that to do the troubleshooting, you need to understand architecture. You need to understand every single layer which is involved into that particular workflow, in that particular traffic flow. Until unless you do not understand each and every layer, as you could see in this particular slide, if you do not understand every single layer, how would you know where to troubleshoot? And how would you build that architectural mindset? And that's exactly the reason why GoVMlab was created, guys. And that is the exact reason why at GoVMlab, we have created a very unique program called vSphere 8.x 0 to hero cohort. This is not just another VMware course. And this is where we have seen a lot of professional, a lot of learners get confused and they start comparing our flagship Zero to Hero program with any generic VMware course. And that is the exact reason I wanted to highlight. And that is what we are trying to highlight again and again, that this is not just another VMware certification program or VMware administration program. This is a structured, mentor-led enterprise transformational program. It is designed specifically for professionals who are struggling to crack interviews. It is designed specifically for professionals who are stuck in repetitive L1, L2 support roles. We do receive call every single day where a lot of people are stuck with the basic L1, L2 rules and they are not finding out a way that how do I get myself to the L3, L4 rules? How do I crack those interviews to position myself for the L3, L4 rules? This program is designed specifically for those professionals who are unable to grow beyond basic administration. This program is designed specifically for professionals who are lacking a real enterprise troubleshooting confidence, a real enterprise confidence into this VMware technology, in spite of having VMware experience, in spite of working on VMware product, in spite of having administration learning. Remember, because the biggest challenge most engineers face is not lack of hard work. We know every single engineer, every single learner, every single professional is working really hard. So it's not a lack of hard work, guys. It is a lack of structured enterprise guidance. What you are lacking is a right guidance, a right structured enterprise guidance. You have been putting a lot of effort, a lot of learning, a lot of hard work you're doing it to learn every single thing, right? But still the confidence is not there and you're facing rejection challenges for taking yourself to the next role because of the lack of structured enterprise guidance learning. And that's exactly why this cohort is personally led by me, Neeraj Mantri. So hi guys, I'm Neeraj Mantri. I'm a VMware and cloud security architect with 19 years of enterprise infrastructure experience. Coming from a research and development, I do have 8 patents on my name. And GoVMlab is a platform where we have been nurturing professionals and it is being trusted by engineers worldwide. Why? Because we always believe that enterprise thinking cannot be learned from documentation, from tutorials alone. And we always believe that enterprise learning must be mentored. And that is where you could see that this program, this unique program, what we have developed, this program help engineers to move from basic administration, basic administration to real enterprise infrastructure thinking, understanding storage behavior, understanding the failures, troubleshooting like an expert, solving those failures with the confidence and stand out into the interviews and building a career that actually scales. And that is the key difference, guys, between learning VMware and mastering VMware. And this is very important because today we know that everyone wants to learn VCF. Everyone wants to learn VCF, which is VMware Cloud Foundation. But the reality is that if your vSphere fundamentals, if your vSphere fundamentals itself are weak, VCF will always be or feel complicated to you. Because VCF is built on vSphere, networking, storage, cluster, HA, and enterprise infrastructure design. So we always recommend to our learners community that before mastering VCF, you must master vSphere. And that is exactly what this cohort is designed for. So if you guys feel stuck in your current role, if you guys feel underconfident during your VMware interviews, if you feel confused in your production troubleshooting, and if you feel unable to move towards architect level of thinking, then this is the program, guys, which can generally change the direction of your VMware career. Because this is not just about technology, it's about your career transformation. So now, if this 1 hour of episode, guys, helped you to think differently, if this one lecture helped you to imagine what happens under infrastructure, right? How this production failure happens. And if this particular lecture helped you to think differently, then imagine what will happen in a complete 100 hours of learning program, because this is just a 1 hour of lecture, what we have tried to explain you. Imagine what would happen when you get exposed to 100 hours of enterprise grade learning. And that is where we would like you guys to invite for our weekend live sessions, interactive sessions, hands-on labs, and understanding real production scenarios, mentored by me and having and giving you the architecture level guidance. And honestly, guys, this is real transformation beginnings. So now, anyone who are aligning with the challenges what we have discussed, GoVMlab is designed for you. Join GoVMlab vSphere 8.x Zero to Hero Career Transformational Program and start thinking like a real enterprise engineer. Thank you, guys. Thank you once again for watching. And I'll see you guys in the next episode of Why Engineers Fail with the next new set of questions and scenarios. Thank you once again. Please like, share, and subscribe to GoVMlab YouTube channel and keep supporting us.